Okay, then let's get started with the next session. We're going to stick to the topic of performance. So Jörg will tell us how SQLScript and the way you write SQLScript actually influences the execution plan and thus performance. Jörg is a trainer and a book author. He's a well-known expert for the topics of SAP HANA and SQLScript in general. He's been a trainer for many years, knowing about data modeling, performance optimization, and things of the like. And he's the author of a book, SQLScript for SAP HANA, which can be regarded as a standard work in that field. Jörg, over to you.
Okay. Thank you very much. So this is a PowerPoint-less demo. This is not PowerPoint. It's MAP. But of course, it's a demo, but I cannot do it totally without some slides. So I talk about SQLScript, not optimizing. It's more about not optimizing code. It's about writing clean code, because when you want to optimize your code, you will fail very often. So Markus already said the most important things. So I can skip the slide myself, and I can show you the slides of my company. And now I start with a scenario that I want to show you today. It's quite small. It's the same scenario as in my book. It's about a task management system. A task has a user assigned. This is the assignee, the one who should do the task. There is a project for each task and a project manager for each project, which is also a user. This small scenario I've chosen for my examples here. I have only these two examples. Code on the left is selecting, I hope you can read it. It's selecting some relevant tasks, selecting the details of the assignee, first name, last name. It's selecting in the next step the project information, and then the last step it selects the project manager's first name and last name. It's quite a small scenario that everyone could understand. And on the other side, I tried to optimize it, do everything in one single step. But the result set of both queries is identical. It's really the same, 100%. What do you think? Which one is faster? The right one. It's just one single step, no variables to remember. So we are doing a good thing for the HANA. So HANA can relax. It's just one statement. That's very often what people think. And now I stop with the slides, and I want to see what HANA is doing with my code. It's quite easy. I'm using here Eclipse and the SQL console, and I want to execute it. And I want to execute this code. And of course, I don't want to look at the execution time, but at the execution plan. So I go to Plan With, Visualize Plan. I click on Execute, and we will see that we have here a logical plan. That's important. I don't want to see the physical plan details. That's too much for... I have a problem with the bar. You cannot see it, but it's right over the important buttons. So now I have it. Yes, I found it. So now I wanted to make it full screen, that it's visible for everyone. And you see here, this was the step-by-step solution. And we see just one big single join node here. A join node left outer many to one 3 times with our 3 tables. They're occurring here 4 times because the user table is queried twice. So you see, this looks like a single step, one big join, and it's identical to the other. Where is it? I have not copied. It's identical to this one here, to the execution plan of this one. And it's not only similar, it's identical. I want to show you this one. So I execute it, show the executed plan, and here we are. We have one big join node, and when we switch between them, where are they? When we switch between them, you see the difference? No, there is none. And that's the magic of the optimizer. The optimizer tries to understand what is your intention of the result set, which results set is described, and not the path to get this. And that's quite important. So there are no optimizations possible when you describe the same result set. We can have them here next to each other. When you describe the same result set, you'll get the same execution plan. So there is no need to optimize in any way. So you can write small, readable, debuggable steps instead of one big query to hide all your logic, and to increase the complexity, because bigger queries, especially if you use subqueries, are increasing the complexity for reading. So this is the first 6 minutes. Okay, we are in time. Now one can ask, okay, what if we use a where condition in the last step here? What if we use a where condition here in the last step, in the last select? On the first table, will it be pushed to the database access, to the table access? Okay, we'll try it out. Where status in 1 or 2. Then we need an additional column here, the status, and we execute it. I visualize plan, execute. Now I have to bring this together, and here expand all. And yes, table access. On the table level, we have here this predicate status equals 1 or status equals 2. So this works fine. There is no need to optimize. And I can show you the exactly same thing for the other query, but I think you believe me. It's one query, of course, it will work fine. Okay, but now something, not so obvious. I change my predicates. What is the expectation? What do you expect? The same execution plan? The same. Okay. And I've found no one who can explain it to me. I'm showing this to such a big audience because I want someone who says, I know why. We have so many SAP experts here, SAP employees, so maybe one of you can tell me why. Expand all. Now the hex engine is involved. There are other sessions here about the hex engine. I'm quite interested, but why? Here we have the hex engine. It's just nothing. I changed, so it's just a small change from a predicate 1 or status equals 1 or status equals 2 to status equals 1. The execution plan flips to the other side. I don't think it's a dark side. I think it's a good execution engine. But the important point is you don't have it under your control. You can't write the code in this way or that way, except for hints. to force the system to make a special execution plan. And this is, yeah, what's okay. We can increase this example now. Status equals 2. Which plan is chosen? Random. You cannot tell in advance. You cannot tell. And now we get back the column plan again from the column engine. Yeah. So I have no idea why. But the important point is don't write your code in a certain way where you think it's faster. Write it in a readable way, in a well-structured way that human beings can read your code. This is more important. And then, I go back to the slides. Then when you don't optimize your code, before you have a problem. When you have a problem, of course, you have to think about optimizing, but before optimizing came analyzing. Analyze your code, have a look, the problems are. Often these are logical problems. Often you see in the execution plan that you can improve something from a logical perspective, but don't try to write your code. Don't be an experimental programmer. Try to do the things structured. And when you have analyzed it, then maybe you find out that a hint or something else can help. I have a collection of some very, very nice quotes. The first one, Donald Knuth, this is 50 years old. My birth year. It's 50 years old. Before 50 years, he said pre-major optimization is the root of all evil. And I think it's still valid. Don't try to optimize something that is working fine. And when you want to optimize it, do it with a good analysis in advance and be careful. Programming with go-to statements. That's really funny. It was years before the invention of object-oriented programming. So that's what I wanted to show. And yeah, thank you very much for attending. I think we are good in time. I'm too fast.
Jörg, thank you so much. So the one thing that I learned is that hex can only count to 1. That's fine for me. Yeah. We're open for questions. Who wants to go first?
Hi, thanks for this great and unexpected insights and great presentation. I have a question. You showed this with Eclipse, so the HANA Studio. Is there an equivalent also in BAS or VS Code extension?
Yes, there is the SQL analyzer for BAS and VS Code, but I'm using Eclipse because all my customers are using BW for HANA, and in BW, Eclipse is the modeling tool, and that's why I prefer Eclipse. Not because it's better, it is not. SAP has stopped innovating Eclipse HANA tools a decade ago, which is really a pity. But for the BW customers, this is the standard tool. That's why I'm using Eclipse.
Okay, thanks.
And I can add to that the optimizer plan visualization also works in dbeaver. So for both of you who stick to open source tools. Other questions?
Thank you. So you said something about the physical execution of these two different variants of the same code. for me, it would be interesting the memory usage and the reusage in this sequence execution. Will it be everything kept in memory, all that you assign in these variables, or would it be somehow reused in memory terms? So it means if you would like to process a huge amount of data, would it somehow help the sequential execution, or
No.
No.
No, the logical plan describes what the system wants to plan. The physical plan is on a column basis, exactly how it's implemented, but it will not help for a bigger amount of data. This step by step seems no, it's not. There's no difference in the execution plan.
Yes, you never mention common table expression in your exposure.
No.
Common table expression being the more natural new way of stacking several select statement.
Interesting point. Can I have the
Can you share
screen?
screen again? We
Screen
still have 5
again?
minutes. Yeah.
Because common table expressions internally the I have to share. Thank you. But where? Here. So I share again, because internally these are these table variables, which is for SQLScript, for example, for AMDP. You don't have an alternative to this. You can use common table expressions. The nice thing about common table expressions that they are standard, but from a readability perspective, table variables I like more. But at the end, it's exactly the same. When we just have a look here and have a look at the explain. Now, where is it? Somewhere you can see it's at the end, or is it here? You see here the with statement. These are your common table expressions. So common table expressions and table variables are the same. It's just another way to write them, and table variables are more, I think they are a little bit more intuitive, but technically it's the same. Thank you for your question.
Okay, one more over here.
Jörg, I have a question. You said the HANA optimizer is quite an uncontrollable black box. What is on your wish list to make it more controllable, or maybe more get faster results?
The HANA optimizer does a good job. And normally we should rely on the HANA optimizer. This is my message. And in these rare situations where we have a problem with the HANA optimizer, yeah, then it's difficult. We have hints. On my wish list, a better documentation of the hints would definitely help. But in general, I'm happy with the optimizer. And I think it's a benefit that we don't have to optimize so much. HANA is doing it. So a black box. Yeah. Somehow,
Okay.
and it would be nice when we have had some more information about this decision making. Maybe an insight in the different options of the execution plan that HANA is considering. But
Okay, thank you very much. One last question over here.
At first, thanks a lot for the very insightful presentation. I have to make a statement in regards of comparing CTE and table variables. The big advantage of table variables is that you can see the intermediate states if you have to do a problem analysis. That means in the flow, in the batch, you can run selects on the table variables and you see the status of the data, which is produced by every step, which is a big advantage compared to CTE, where you never know what happens in between. So that's simply my 3 cents on that.
That's true. You can debug at the end and find out what's in each table variable. So that's definitely a benefit.
Okay, with that, I would like to close the session because we have a tight schedule, but I will ask Jörg to be over in the expert corner on this floor just around the corner. So he'll be there and you can hunt him down and ask him anything you. Okay, thanks again, and another round of applause, please.